So today we're going to work through finding the reading on this voltmeter. This should really be the hardest thing you do at school because any harder circuits are kind of pointless as circuits do not carry over at all into year 12. So we need to break down the analysis of this somewhat complex circuit into a series of steps. And step one is to solve for the overall resistance of the circuit and figure out the total current through the circuit. So let's start working our way towards that now. Our first step is to reduce this entire circuit to one single resistor. And the best approach is to start with the most parallel part of the circuit. The most parallel part of this circuit is the 30 ohm and the 10 ohm. So let's reduce that first. Using our parallel resistance formula, we can reduce the 30 ohm and the 10 ohm to a single resistor of value 7.5 ohms. We've now modified the circuit to reflect this. Now what you can see is there's no more parallel in parallel. We simply have two series resistors up the top and two series resistors down the bottom. So all we do now is we just sum the series resistors. So at the top, we're going to get one series resistor of value 90 ohms, and down the bottom, we're going to get one series resistor of 27.5 ohms. Awesome, done. Now let's use the parallel resistance formula on this parallel combination. We now find the equivalent resistance of this parallel part is 21 ohms. So we can change it to one single 21 ohm resistor. So now we simply have two series resistors, we just add them as normal, and we end up with one resistor of 41 ohms. Now we've got the total resistance of the circuit, we can use the total voltage across the circuit to find the total current through the circuit. So we end up with the total current through the circuit as 9 on 41, or 0.22 amps. Now we can use this and go back to our original circuit to figure out the voltage between those 2 points. So we've solved for the total resistance and hence the total current through the circuit. We now need to use this total current to figure out some voltages and currents through the other components. So I usually say to my students, it kind of happens in two steps, and you find yourself flipping back and forth between the two. And that is, you either use current to find voltage, or you use voltage to find current. And as I work through, you'll see what I mean. So we figured out the total current through the circuit is 0.22 amps, and we want to use this current to find out the voltage across a component in the circuit. So which of these resistors does the entire circuit current flow through? There's only one, and that is the 20 ohm resistor. So I can use the current through the 20 ohm resistor to find the voltage across the 20 ohm resistor. So I get the voltage across my 20 ohm resistor is 4.4 volts. Let's add that to the circuit. And it's important to recognize what this means. What a voltmeter does is measure potential difference. So it's telling us across the 20 ohm resistor, 4.4 volts of potential is lost. Now, seeing as the left-hand side of the 20 ohm resistor is directly connected to the 9 volt terminal, this means the potential on the other side of the 20 ohm resistor is 9 minus 4.4. So let's add that to the circuit now. So this means any point after the 20 ohm resistor, which is just connected by a wire, is at 4.6 volts. Because we assume there's no voltage drop in the wire. So if it's 4.6 volts directly after the 20 ohm, it's also 4.6 volts at any point before it goes through any other load, that being a resistor or something. Now, if you have a look at the other side of the parallel branch, you can see this is connected to the 0 volt terminal. So the potential all along this wire is also going to be 0 volts. So let's add that to the diagram. Earlier, we simplified the 30 and the 10 to a single resistor of value 7.5 ohms. So let's add that to the circuit. And let's place our voltmeter back in the circuit. So remember what a voltmeter does. The voltmeter measures the difference in potential between 2 points. So in order to find the reading on the voltmeter, I need to find the potentials at those 2 points. As you can see, we've got the voltage across each parallel branch as 4.6 volts, and we're going to use that voltage to find the current through each parallel branch. So I've denoted the current through the top branch as I1 and the current through the bottom branch as I2, and we get 0.05 amps through the top branch and 0.17 amps through the bottom branch. There will always be some rounding errors, but notice the 2 dp, it's the same value of current. 0.22 amps, 0.22 amps. Now that we have the current through each branch, we can figure out the voltage across resistors in the branches. So we can find the voltage drop across the first resistors in each parallel branch, subtract that from 4.6, and that'll give us the potentials at V1 and V2. We've now figured out the voltage drop across the 40 ohm and the 7.5 ohm, and we subtract this value from the potential of 4.6 before the resistors. So using that, we get the potential after the 40 ohm as 2.56 volts and the potential after the 7.5 ohm as 3.35 volts. Now all a voltmeter does is measures the difference in those potentials. So it's 3.35 minus 2.56, which gives us 0.79 volts. And that, my friends, is the reading on the voltmeter. Easy peasy, got you some extra marks.